Hello students, we'll be going over 19.3, that's the surface area of a pyramid, and going over a cone. So to find the surface area of a regular pyramid, what we're going to do is the lateral area plus the area of the base. So again, for this shape now, the area of the base will be that bottom rectangular figure, or it could be triangular figure as we go through it. Or more specifically, to find the lateral area, to find these triangles that all line up on the side, it's 1/2 the perimeter of this base times the slant height. So we're going to look for this height that comes at a diagonal. So like for example, they give us the slant height here. Other times they won't give us, so we'll have to use the Pythagorean theorem. So one thing I always point out is this is a base. If they just give you one dimension, we can assume it's a square pyramid. So this side's 5, this side's 5. So first thing we want to do is we want to find the area of the base. So that would be 5 times 5. Plus, then we go 1/2. Now we do the perimeter of the base. So 5 plus 5 plus 5 plus 5. So perimeter of the base times the slant height. In this case, they give us a slant height of 9. So we would go 5 times 5 is 25, plus 5 plus 5 plus 5 plus 5 is 20. Times 9, half of 20 would be 10. 10 times 9 is 90, so it's 25 plus 90, which is 115 inches squared. So again, we want to make sure we have our units squared. Biggest thing is understand we need the slant height as we go through it. Perimeter is something a lot of students forget. So you can write it here where P stands for perimeter, so it's 1/2 the perimeter times the slant height plus the area of your base, whatever shape that may be. So we'll go to the next one. The next one's an example where they don't give us the slant height. And so we have to go ahead and find the slant height. So again, once we will look at the base. The base is this square, 10 by 10 square. So I just want to point that out. So it's 10 by 10. Now, if we look at 10 goes all the way across, this is going right to the center. So this is 5 here. So half of 10 is 5. That's where I get that. We have this right here. That's straight up and down. That's 12. That's our altitude or our height. We want the slant height. We want this. So we have to set up the Pythagorean theorem. 5 squared plus 12 squared equals that L, that slant height squared. So that's 25 plus 144, which is 169, equals your slant height squared, and then take the square root of that. So your slant height is 13. So again, we find the area of the base. That's 10 times 10 plus 1/2 the perimeter of the base. So perimeter is 10 plus 10 plus 10 plus 10, which is 40, times your slant height, which we found to be 13. So again, it's important that you understand this. This is the area of the base. This right here is the perimeter of the base. And this right here is our slant height. So write it out so you can continue to go through your notes looking right back at it. So 10 times 10 is 100, plus half of 40 is 20. 20 times 13 would be 260. So this would be 360 meters squared. Make sure you always put your units squared as you look at it. So now we'll look at the area of a cone, the surface area of a cone. Surface area of a cone follows a lot of the same, it's the same principle. It's the area of your base plus what we'd say, instead of half the perimeter of the base, it'd be half the circumference of the base times your height. So when you come out and do that, it actually comes out to your surface area is pi times radius times L. Okay, so this would be, this is called the lateral area is right here, pi times radius times the slant height again, slant height. And then the area of your base is pi r squared. So again, we need to find the slant height. So we do Pythagorean theorem. So we go 6 squared plus 8 squared equals L squared. So that'd be 36 plus 64 equals L squared. That's 100 equals L squared. And you take the square root of that, which is 10. So that would be your slant height. So then, taking our equation, it's pi times your radius of 6 times your slant height, we just found is 10. This right here is our lateral area, plus the area of our base, which is just pi times your radius of 6 squared. So 6 times 10 would be 60 pi, plus 6 squared would be 36 pi. They may ask, so they could ask for two ways. So they may say, hey, give it to me in terms of pi. So it'd say it's 96 pi centimeters squared. Or if they said, go ahead and round, we multiply, and that gives us 301.6 centimeters squared. And usually we're rounded to the 10th place. Next one is similar issue, similar deal. So we want to find the surface area of this. In order to find the surface area, we need to know the area, or we need to know the slant height. So we know the slant height is 25. We know the altitude is 24, but we don't know our radius. So we need to find the radius of our object. So when we do that, we're going to do the same thing. So we go ahead and set up the Pythagorean theorem. R squared plus 24 squared equals 25 squared. And we go about it the same way, looking at it. So we come through here and then subtract it. I'm going to kind of jump ahead. But when you do this, so you go 25 squared minus 24 squared. And then take the square root of that. So when we do this, so I'm going to subtract it. So r squared will equal 49, and r is equal to 7. So then, once you have that, then it's pretty simple as you go through it. So it's pi times your radius of 7 times your slant height of 25 plus the area of your base. So pi times your radius squared. So 7 times 25 would be 175 pi. Plus 7 squared would be 49 pi. And then we add these two together. So it would be pi 4 12. So it would be 224 pi centimeters squared. So we'll leave it in terms of pi. So then we'll go to composite figures. As you look at composite figures, so when I look at the composite figures, I'm going to start here. So I'm going to first look at this. I need to find this area, which I can do. That's a circle. So then the cylinder is the circumference. The lateral area is the circumference times your height. So we're good there. We don't need to find the top of the cylinder, and we don't need to find the bottom of the cone because it's covered up. But we do need to find what we call the lateral area of our cone, which is pi, so we got that, times our radius, so we got radius, times our slant height. Now, we don't know this slant height. So from here to here is 45, and we know from top to bottom is 90, so we know this height right here is 45. So we need to do, and this is 28, so we need to do the Pythagorean theorem again. 28 squared plus 45 squared equals our slant height squared. And so when you go through that, you're doing the same thing. And so we would have this. If you did all of this and then took the square root, you're going to get your slant height equal to 53. So our slant height is 53, just using Pythagorean theorem. So that's 53. So once again, I'm going to do the area of this base. So that's pi times your radius squared times 28 squared. So this is the base of the object. Then I'm going to do the lateral area plus the lateral area of the cylinder. So that's pi times your rate, or pi times your radius times 2 times that height of 45. Plus, now I'm doing the lateral area of my cone. So the lateral area of your cone, which you just went through, which is just pi times your radius, 28, times your slant height of 53. Okay, so I labeled it, base, the bottom of our shape. Then we did the cylinder, the lateral area of our cylinder, and then the lateral area of our cone. In which case, it is equal to, this is 2,000. And again, I'm rounding here. This is equal to 7,016.8, 916.8, and this is 4,662.1. And then we add these all together, and we get 15,041.9. And again, this would be centimeters squared. So break it down into the different objects that are overlapping or not overlapping as you look at it. Last one. So we look at, now we have a pyramid, and in this case, we have a pyramid and a cube. So we want to find, again, the surface area of this object. So we need the surface area of this cube, but not this top because it's going to be open. So I'm going to find the area of this base right here. So I'm going 2 times 2. So this is the bottom. If you look at it, area. Now I'm going to do the lateral area. So I'm going to do this base, left, right, front, and back. So it's going to be the, if I look at this, the distance around it, the perimeter, so 2 plus 2 plus 2 plus 2. So it's plus 8 times my height of 2. Okay, so this is the lateral area of the cube. Now, we have this pyramid that's coming in. I don't need the bottom of the pyramid. I just need, once again, I need this, what we would get is the lateral area. So to find the lateral area, it's 1/2 the perimeter of the base times our slant height. And that's the issue that we have. If I went from here straight down in the middle, okay, this would be 2 units, straight up and down. If I went from this center over, so think about it, if you went from the center here over, the whole distance is 2 yards, so this would be 1. What we need to find, and I'll go all the way over here, what we need to find is the slant height that's coming up. We need that. So we have to do Pythagorean theorem. 1 squared plus 2 squared equals L squared. So that's 1 plus 2 squared is 4, so this is 5 equals L squared. Take the square root of 5, and that's 2.2 equals your slant height. Okay? So, I'll do it out here. Plus 8 times 2 is the lateral area of your cube. Plus, now we're going to do the lateral area. 1/2 the perimeter, 2 plus 2 plus 2, or I could do up here 2 plus 2 plus 2 plus 2 of 8, so 8 times our slant height, which was 2.2. And so this is the lateral area of your pyramid. So 2 times 2 is 4, 8 times 2 is 6, and then 1/2 of 8 times 4 so 4 times 2, so this would be 4 times 2.2, which is 2.2, which is 8.8. So it's about 28.8. There we go. And this would be yards squared as we look at it. So it's important as you guys look to go through it that you understand that idea of lateral area and area of the base. that we need to, for cone and pyramid, we need the slant height as we work through it. And then to find the lateral area, it's the distance around what we call the base, what we're classifying as the base, times that slant height as we go forward.